Hi, my name is Katie, and I'm a cloud platforms engineer for Conde Nast International. And today I would like to talk about HPA VPA Federation and how can these techniques be used to approach scalability within a Kubernetes cluster. Before I move on, my clicker is not working anymore. I would like to talk a bit more about Conde Nast. If you heard about any of these magazines before, this is pretty much us. Conde Nast is a media publishing company that has been around for more than 100 years. And we are operating in 11 European markets, 5 Asia-Pacific markets, and we have a Conde Nast US as well. In terms of the cloud platforms team, it's working. What our mission is, we try to focus on the scalable, reliable, and highly available platform with a very robust delivery process. So this is what we try to achieve, and this is why we look at the scalability techniques. Some of them we use them in the cluster, some of them we are trying to include them in the cluster in the future. So in terms of my agenda, today I'm going to talk about the HPA and how can you scale the amount of replicas for an application within a cluster. I'm going to talk briefly about the quality of service and how the resource requests are important for your application and the placement of your application in the cluster, and how the vertical pod autoscaler can help you with that. And in the end, I'm going to talk about how can you deploy application on multiple clusters, because that's what's very common nowadays, and that's what we really want to do. Without further delay, HPA. When you think about the HPA, pretty much most of you already use that, and what it actually provides is a mechanism to automatically adjust the number of replicas for a specific application based on some metrics and resources. HPA has been around for a long time. It has been introduced in 1.1 in Kubernetes, and it has the support for resource metrics. When I'm talking about resource metrics, I mean CPU and memory mainly. In 1.6, we'd be able to scale our application on custom metrics, which means any metrics provided within the cluster, you can scale application on that. And in 1.10, this is quite exciting. It's from last October. We can scale on external metrics. So if you have any events within your cloud provider, you'll be able to scale on that. If something happened with your database, or you have the queue of your SQS is big, you can actually scale your application based on that event only, or you can scale down accordingly. So obviously, when you're talking about the HPA, it's important to talk about the metrics provider. If we talk about CPU and memory, we're going to look at the metrics server, which can be installed on the cluster as an add-in. If you look at the custom and external metrics, pretty much what you're going to look at is an external provider. The cloud native one, which is going to be Prometheus, I think that's quite popular. In-house, for example, we use Datadog Cluster Agent. Looking at the workflow, this is very straightforward. I try to keep it very simple in terms of the diagrams. Once you have an HPA object defined, we're going to check with the metric server or the metric API provider if the threshold is met. If that is met, then we're going to change the amount of replicas. This means we can scale up or down accordingly. So you have just the right amount of pods for your application. It is important to mention here that HPA works with all the resources within Kubernetes that extend the scale sub-resource, which means it's going to work with deployment and replica set, but it's not going to work with something like daemon sets. If we look at the definition for a horizontal pod autoscaler, what we want to look at is the spec section here. What we say pretty much is we will scale up to 3 replicas if our condition is met, and if we scale down, then we'll have a minimum of 1 replicas. In the metric side here, we scale on external metric, and in this case, it's going to be network requests per second, and for a very simple purpose, we put the target to 2, saying that if you have more than 2 requests per second, then we're going to scale up. This is pretty much straightforward, but this is a very, very powerful mechanism which allows you to control your application with events outside of your cluster. Next, I would like to talk about the quality of service. Quality of service are classes which are used by the scheduler to place or evict a pod from within the cluster. Now, this is quite important because if you do not set the resources required for your application, you're going to be assigned a best effort class, which means your application is going to be evicted pretty much with a very high priority if something happens within the cluster. Where you really want to be is within guaranteed and burstable quality of service classes. Now, to be a bit more precise of what it actually means, if we look at the deployment, what we look at is the requests And here we have, for example, a burstable quality of service class, mainly because the limit CPU is higher than the request CPU. As a developer, you really want to maintain these values up to date because you don't really want to starve your application of CPU. You don't really want to deal with out-of-memory events. This is where you actually have to keep a very good eye on and make sure your application has enough resources to run in the cluster at all times. This is a very tedious activity, especially when you have multiple applications. That's why we have VPA. So VPA is actually this mechanism which assigns these CPU and memory values for your application. It's always going to be up to date, and everything is automatic. It's like a tool that provides that for you. Vertical pod autoscaler is not a resource supported in Kubernetes. It is a custom resource definition, which is in OpenInfra at this point, and it requires Kubernetes 1.11 versions as well, but you're going to have a different version of the VPA itself. The VPA is composed of three components. You're going to have an admission controller, a recommender, and an updater. The recommender is going to look at your metrics, or like, let's say, for the usage of your application in terms of CPU and memory, and compute some values of what your application actually uses now and what it actually requires at the time. The updater is going to take these values and is going to make a decision if your pod needs to be recreated with the new values altogether. And the admission controller is the part where once a request is sent to the API server with the new values for memory and CPU, the admission controller is going to intercept that and place the right values on the pod. So when you actually have the pod recreated, it's going to use those values for CPU and memory. It is worth to mention the VPA does not change the definition of a pod. If you still describe a deployment or a pod, you're going to see the values that you set manually. However, the admission controller is going to make sure that the right memory and CPU values are used. And the source of truth within this case is going to be within the VPA object itself. So what actually VPA tries to achieve, the purpose of it is to reduce this maintenance cost of configuring the resource request for an application, as well as it improves the utilization of your resources because you're never going to use more or less than you actually require in terms of CPU and memory. It will minimize the risk of out of memory as well as of the CPU starvation as well. In terms of the diagram, again, very simple, straightforward. Once a VPA object is created, the recommender is going to check with the metric server for the CPU usage and memory usage. The updater is going to make a decision if those values should be changed. And then when you actually create a new pod, those values are going to be changed on the deployment itself. And that's going to be done by the admission controller. So in this way, you can allocate just the right amount of resources at all times. In terms of the definition, this is very straightforward. Here you just have a selector saying that I really want to watch my application, which is Nginx, and I have an update policy, which is going to be auto. In terms of the update policies, we have 4 of them. Actually 3, but this is going to be a bit more clear in a short while. The auto policy, it tries to assign and update the resource request for an application, but it aims to be restart free. The recreate is going to do the same thing. However, it will evict the pod, and when it recreates it, it's going to have the new values. At this stage, the recreate in auto does the same thing, mainly because it is impossible to update the pod without restarting it. So I think they have an aim to fix that, but currently it is not possible. So auto and recreate is pretty much the same thing. When you're talking about initial policy, this means that the requests are going to be placed only when the application is created or the pod is created, and we're never going to touch it again. And off means that no changes are done to the pod or whatsoever. However, the VPA object is still going to calculate the usage, and you can use that as a point of reference, if any. And I have a demo. This one I have pre-recorded. Please let me know if you can see things. Oh. Right. Is this visible enough? Is it too small?
A little bit bigger.
A little bit bigger. Right. Let me just stop that. I know this is not the ideal, but I'm going to talk you through what's actually happening here. So this is one of the applications. So this is better, yeah. This is our pod autoscaler definition. Just up there, we have an auto policy. which means we're going to recreate the pod to update it with the new values for CPU memory. Here you actually see below, just over here, we have the CPU memory value set to 5 millicPUs and 5 megabytes. And this is just a deployment which is just going to create crazy load and, spike on CPU ideally. Now, once we deploy that, yes. So we deploy that, I apply that from a file, and now I'm actually looking at the VPA object itself. I'm not just going to scroll a bit down here. This is the recommendation given by the recommender itself. So what we want to look at is the target. Now, we said we want 5 millicPUs. The VPA object says your application requires 25 millicPUs, mainly because we have that crazy load happening in the background. As well, in terms of, I think the memory value is pretty much the same. Actually, no, it's not. We wanted 5 megabytes. Here we have 262,000 kbytes. So it's quite different. And this is going to be updated. This value is going to be kept for a while, and then it's going to update the pod itself. Here you can see that we have a lower bound and an upper bound. At this point, it's the same because the initial recommendation is going to be changing over a while. But once a lower bound is reached, or an upper bound is reached, then the pod is going to be recreated with those new values that are required. And I think what I'm doing next, I'm just watching the pods. And I'm just going to fast forward here because in a minute and a half, pretty much at the 90-second mark, it will actually recreate one of the Nginx pods, and that's what it's actually going to have as new values. Here it is. So one of the pods has exactly the right amount of resources. And I think the last thing which I'm doing is to look at the events, and I'm just going to sort them by timestamp. If you look at the events for the VPA, right. What we're actually going to look at is the evicted by VPA, and we're going to see this is how we can identify why the pod was recreated as well. So we can correlate these two events. Right. At this point, we talked about how can you scale the right amount of replicas for an application. We talked about how can you allocate the right amount of resources. Now, what happens when you have a lot of load coming from all around the world? This is where federation comes into play. If you really want to distribute an application and have a centralized mechanism of applying a manifest centrally and is going to be replicated within other clusters, federation is probably something you want to look into. Federation is actually a good answer if you want to migrate deployments and services between the clusters. This is due to the higher level API behavior it has and handles. So when we're talking about federation, the link we actually make straight away is with SIG multi-cluster. SIG multi-cluster has been around for quite a while, and it has 3 projects within what it's actually focusing on. We have Federation V1, which currently is deprecated and is no longer under active development. We have Federation V2, which requires a Kubernetes 1.11. We have the cluster registry, which is the second project, and the cluster registry is a tool that will maintain a list of clusters and the data used to connect to those clusters specifically. And we have a tool which is called kubemci as well, which will provide the multi-cluster ingress or the layer 7 load balancing. What we're going to focus on today is going to be the Federation V2 and the cluster registry mainly, and I'm just going to show how these actually talk together and we can actually deploy within a Federation cluster. So Federation itself, when you think about it, it's very important to think from the point of view of managing an application on multiple clusters using the cluster registry. This is not like a tool to manage the clusters, it's more about the applications and how can you deploy them. Talking about Federation V2, this means that there was a Federation V1. So what happened there was that in Federation V1, they tried to wire the code for Federation within the Kubernetes code. And that didn't work really well because it tried to come with an API endpoint by itself, and it tried to kind of keep up to date with the Kubernetes code releases, which was not very maintainable at the time. In in Federation V2, the approach is quite different. They use microservices and they use the building blocks approach to provide, which uses the Kubernetes API instead of providing a new API service. It makes a very good usage of the custom resource definitions, which was not so popular of a concept in V1. Hence, it's been more of a success for Federation v2. When we talk about Federation v2, we need to we need 2 points of information that we need to feed to the clusters. First of all, what we need is the configuration, the cluster configuration. Here we're going to say what clusters Federation can target. And the type configuration is where we're going to specify the custom resource definition for a federated type. For example, if you want to federate a deployment, Federation will require a federated deployment CRD. And its template is going to be very similar to the deployment template, but you need 2 points extra of information, which is the placement, and say this application should run in these clusters, and the override, which allows you to have different information or different specs between the clusters for the same application. Again, when we're talking about Federation v2, that means we have multiple clusters. It is important to have one hosting cluster where we're going to have the Federation controller manager, and we're going to have the cluster registry in the same on the same hosting cluster as well. When we look at the diagram for Federation v2, it looks very scary and it's quite overwhelming. However, it's pretty straightforward. We talked about the type configuration, the template placement and override. That's how we actually define how a deployment should be propagated within a cluster. The propagation itself is going to be handled by the controller manager. And it's going to make sure that we have the right amount of replicas running at all times. This is coupled with the cluster configuration, which means it will have a list of available clusters where you can run your program or pods. On high-level behavior, we're going to have the DNS and scheduling. These are quite important features. It's kind of quite a new concept. The scheduling itself will comply the request from the developers saying that we want 1,000 replicas running at all times in these clusters. If a cluster goes down, then the scheduling will be able to make the right decision based on the policies where exactly the application should be running, to comply with the request in terms of the amount of replicas. The scheduling comes as well with a very powerful weighting system, which allows you to run multiple more replicas in one zone than the other. So you can actually customize it in terms of the traffic coming to your application. The DNS, this is pretty much for services, but if you're required to provide a service on a federation level, you'll be able to do that. As we know, in Kubernetes, we have an in-cluster DNS name. To be used by internal services. This DNS feature will allow you to customize your service on Federation. So the endpoint itself is going to be based on Federation itself. If you look at a definition, here we have a federated deployment. The spec itself is going to be very similar to the deployment. So we say we have some labels and selectors. Here we say we want 3 replicas for an Nginx application. In the placement section, we say that we want it in 2 clusters, cluster 1 and 2. However, in the override section, we say we want 5 replicas in cluster 2 rather than 3 in cluster 1. So I think this is what I'm going to demonstrate at the moment. Hopefully my clusters are still up and running. Let's see. So, right. Can everyone see? Is it too small? Is it good? Awesome. So what I have here, this is the cluster registry. The cluster registry is pretty much where you have all the available clusters within your federation. Well, cluster which we can include in federation, actually. So here I have cluster 1 and 2. If I get my federated clusters, I'll be able to see that I already federated these 2 clusters into one. And if I describe them, I'll be able to see that this is my, for example, this is my cluster 1, and it's ready and healthy to receive whatever request we send to it. And it's going to be the same for cluster 2 as well, just over here. So what I'm going to do now, I'm going to deploy namespace. So let's look at the manifest for a federated namespace. Oh, not this one. This one. Here we say that we want a federated namespace called test namespace, very inventive. And we want it on 2 clusters, cluster 1 and 2. So what I'm going to do, I'm just going to do a kubectl apply Now, I would like to get all my, I'm going to change the context first of all. And I will say get all my namespaces in cluster 1, which is going to be my hosting cluster. And here I see a test namespace. If I do the same in my second cluster, I'll be able to see that it was created 22 seconds ago. Now, before applying the deployment, I'm just going to make sure that there are no deployments running at the time. So I'm just going to say in my test namespace, get me all the deployments. I have nothing. If I do the same request within my second cluster, I have nothing. Now, what I'm going to do, I'm actually going to deploy a federated deployment object. So this is very similar to what we had on the slides. Here I say I want an Nginx application with 3 replicas. I want them to be in cluster 2 and 1, and I want to say in cluster 2 I want 5 replicas instead of 1 replica. So I'm just going to go ahead and apply this. Now, when I get my deployment in cluster 1 within the test namespace, I'm going to say I have a test deployment with 3 replicas. If I do the same request in my cluster 2, I'll be able to see that I have 5 replicas instead. And this is how you can propagate and control the amount, well, where your application should run or the amount of replicas you want to run in the application itself. Right. I think this pretty much concludes in terms of overview I wanted to give about HPA VPA Federation. In terms of the recap, remember that you can scale the amount of replicas for an application based on any metrics within or outside the cluster, the quality of service and the importance of the resource request for your application, and how can this be automated by the vertical pod autoscaler. And if you're thinking about having a centralized mechanism to deploy application to multiple clusters, that's going to be Federation V2 for you. And I have some references. The HPA itself is quite biased towards the Datadog. That's mainly what I used to research this topic. And I think, yes, we're hiring. If you would be interested to find more about the projects we do or what we have envisioned for the next, 6 months in terms of tech, please talk to me. And that's it. Thank you. Yes, please. Right. I'm pretty sure you can have a federation in GKE as well. It's something supported within. I did not research it within the Azure. VPA is available, I think, within all the clusters. I don't think there's any issues with it, really. But for federation, I've seen very little support for multiple providers. In this case, I had a kind of a bare metal use case. But I know they have support for GKE natively. Nothing for Azure, I'm afraid. I don't know, at least.
So another question on the,
yes, please.
On the gathering of metrics. So you've shown processes which grow within memory boxes which are
yes.
volatile, right? So
yes.
If you run JVM workloads, especially the JDK flavors of that, you'll end up with a kind of box metric within which the applications are confined.
Right.
Where how the metrics provider will be able to gather CPU and memory utilization from within the application VMs.
So this is going to be tightly coupled with the resource metric server within the cluster, which is already able to get these metrics from the application. Now, if you're saying you have a collection of components, right? That's
well,
what
I'm looking at the metrics coming from, for example, the GMX framework. So you launch a JVM, you'll give it a fixed set of memory and CPU capacity within the JVM definition itself.
So you're not going to have the actual used values. It's going to just
so
give you the allocated.
The container wouldn't see from outside what the application is doing on the inside. You would have to gather the metrics from a JMX type interface.
Right. What I would think about here is maybe make those available within the cluster so the VPA can take those in account. Otherwise, it's going to take what it says. It's not as clever as to dig around, I'm afraid. You had a question? Yeah.
Would you use both horizontal pods and vertical pods at the same time?
It is not, well, you can, yes, but it's not the best use case to be in, really. I think the main conception is that HPA is recommended for stateless sets, and VPA is for stateful. Or is it that way around? What I'm trying to say here is that the VPA itself will evict the pods by default, which means that if your application is not restart tolerant, then probably VPA is not something you can look into. It will still respect the pod's Russian budget. However, if you run both of them together, HPA and VPA, you have to make sure you know what to do and how those are going to behave. Because, for example, you have a scale, but meanwhile, VPA is triggering in and you want to restart your pods with like extra replicas. You have to be very aware of these kind of conditions and race conditions between them. It really depends on use case. I would say choose one rather than run both of them because the maintenance cost is going to be too high. But yeah, it depends on application, I would say. Yep, thank you very much.